Hello, and welcome to this Unity tutorial. I'm Josh, and I am here to show you the very basics about assembling a script and talking about its components. Now, before we get into this, full disclosure, I am not a professional at this, and you may be wondering, if I'm not a professional, what value is there to me creating a tutorial for you? To which I would say, because I'm not a professional, I have had to learn how to do a lot of this stuff through watching other people who are very well versed in Unity, and I've come to realize that a lot of people who are super familiar with Unity tend to leave out certain extremely beginner concepts when explaining how to do code. They'll either tell you to just copy something and that you'll understand it later, or they'll use terminology that you may not be familiar with, or they may simply assume that you already know what something does. Like, it may be something that's so basic that they forget to explain what it is and why. So I'm going to just try to provide you with a very, very bare bones explanation as to what you're looking at when working with a script. We're not going to try to make the script do anything in particular. I'm going to use a couple demonstrative functions, but it's not going to be a tutorial as to how to make an object move around or do anything like that. It's just going to explain the very basics about what you're looking at and why things are the way they are. So, to start off with, we have here a blank Unity project, nothing in it. And the first thing that we're going to do is we're going to come down to this assets folder. We're going to right click and we're going to create a folder. And we're doing this because organization is extremely important in Unity. You're always going to want to have everything organized. So you're going to want to have a scripts folder for when you're making a new script, because you're probably going to have more than one. So then we're going to go into that script folder, right click again, and say create C# script. Now I'm going to make two scripts here. The first one I'm going to call Unity test. And then the second one I'm going to call, oh, hold on. I've actually technically already done this, but the last recording messed up, so please ignore that. Let me delete this. Alright, sorry about that. And then we're going to create another one, and I'm going to intentionally do something wrong here. Alright, so as you can see, we have a script that says new behavior script. I clicked off of it, so it just locked in this name. Now if I double click it, and then I'm going to call it error script, enter, and now that's created. Visual Studios keeps on popping up when I don't want it to. Don't mind that. So now I'm going to open it up, and I have two scripts here. And you can see they start off looking exactly the same. So now I'm going to write a certain line of code. Don't worry about what it says. I'm just going to use a debug.log, which is just going to give us a little readout. I'm going to save this, and I'm going to use this as a demonstration as to why you have to be careful immediately when making your scripts. So we have two scripts that look exactly the same. Now, they're not going to do anything as they just sit here in your assets folder. You have to actually apply scripts to a game object, which is anything that is in the scene, and it'll go under the hierarchy tab. So anything that you see in here is a game object. So I'm going to right click in the hierarchy, say create empty, because we don't need it to be anything in particular, and we're going to drag our Unity test script onto this game object. So now if I click on it, in the inspector tab we can see the script object goes right there. And if I hit play, and I open up the console, this is where the debug.log line that I wrote reads out to. We can see it says test. So that means everything we wrote works correctly. So then I'm going to stop this. I'm going to remove this component by right-clicking and saying remove component, clear out this, go back to the project, and we're going to take the error script. We're going to drag it over, and we're going to get an error. And it says you can't add the script because the script class cannot be found. Make sure that there are no compile errors and that the file name and the class name match. This is the error that we're actually highlighting here. So when I clicked off of the script immediately after creating it, and it said new behavior script as its name, and then I changed it, well, when a script is first created, it doesn't technically write out until it has been assigned a name. So if I open this up, you'll see that even though I renamed it to error script, it wrote out its name when the script first created itself as new behavior script. And this name and this name, which is what it's going to say in Unity, have to match. Otherwise, you're going to get that error. So always make sure to either type out your name immediately, or if it does get locked in as new behavior script, you can change it. It's not a big deal. You can just type, error script or whatever you choose to name your script. Boom. And then we'll go back into Unity, and I can drag this on here, and now it runs just fine. It will go on to the game object without any error. We go to the console, and it reads out test, because now it is a functional script. And in order to make sure that locked in, I had to save the script. So if I go back and I rename this to something incorrect, but I don't save it, and you'll know if its script is saved because it has this little star here. So I'm not going to save it, and I'm going to go back into Unity and play, and there will still be no error because it hasn't updated in Unity that it's wrong. But if I come back here, hit Control S to save, open up Unity once again and hit play, we're going to be given an error saying that the reference on the script is no longer correct. So that's just one thing that can happen right off the bat when creating a script. I bring it up because I've done this on more than one occasion, so I figured I would point it out so you know how to deal with it. Okay, so next we're going to just get out of this script entirely. We don't need it. And I'm going to keep this debug.log around because I'm going to use it a couple times, so I'm just going to copy it to show you a couple things. So the first thing that I'm going to talk about is just the things that are already on the script when it first creates. So you'll notice it had this void start and void update. These are the two methods. Anything that has this kind of curly bracket assembly is called a method. Specifically a curly bracket that is directly outside of this main curly bracket. So curly brackets, I should say, are basically holders for a sequence of things that's going to happen. So you see how it says public class Unity test mono behavior. Unity test is the name of the script. It's deriving from mono behavior. I'm not going to bother explaining what that is. Honestly, I don't understand it to completion, but just know that that's the script as a whole, public class. Anytime somebody refers to a class, they're talking about the script itself. All right, so that's a piece of terminology that tends to be thrown around that if somebody doesn't tell you that can be confusing. And it's always going to have a set of curly brackets to say everything within these curly brackets is what is considered part of the script. And then you can set up other things like the start and the update that are going to have their own set of curly brackets. And then you can have curly brackets inside of those for more conditional situations, and we'll see that in a minute. Now, start and update are already recognized functions, and they each do their own thing. So start is a one-time run call at the very first frame of when the script is able to run. So since there was no condition for the object being created at a specific time, it was already in the scene as soon as we hit play. On the very first frame, it is going to do whatever is in here. And it's going to do it exactly once and then not again. Update, on the other hand, occurs every frame. So I'm going to paste this into here, and I'm going to change the name to test update. So you can see how this call happens. So every frame, everything in here is going to happen. So depending on the kind of code that you're writing and the kinds of functions that you want your code to do, you need to be careful what you put in update, because since it happens so frequently, it can become a very big draw on your processing power. And if you're asking it to do really complex things every single frame, that can become a problem. So while that's not necessarily something that you're going to have to worry about as a beginner, you're probably not going to make anything so big and complicated where that would be an issue. But it's something to keep in mind that if you can have something called on a smaller interval, or maybe indicated by a single action, like if this thing happens, then call another method that happens one time to do whatever the code is, rather than doing it every single frame, checking for something every frame, it can really save your processing power. So before I go back into Unity, I'm going to do one more thing. I'm going to show you one more method, and that's going to be void fixed update. And you see it gives me the drop down because it knows what this is. So if I click this, it is going to fill in the curly brackets and everything. It's going to set up the whole nomenclature the way it's supposed to be, which it puts private. That's not necessary per se, but it doesn't hurt it. Void, which the word void just says that it's not going to return anything. So when somebody talks about returning something, it's if it's collecting and then spitting out a value or an object. Now, this method, none of these methods are going to do that, and by the time you're writing a method that does that, you'll have a greater understanding as to how that works, because it's not necessarily a very beginner-oriented thing. So don't worry about the specifications behind returning. Just know that it's going to do a thing, but it's not going to create something to talk to something else. And that's really what would make you change the word void into some other variable. Sorry if that sounded confusing. The reason why it would sound confusing is because it's not really a beginner type thing, so don't worry about it. Just write it out as void and then whatever your method is, unless you have a good reason to do otherwise, in which case you'll know you have that reason. So I'm going to type out fixed update here, and the reason why we're having an update and a fixed update is I want to demonstrate the difference, and that is that fixed update is called at a very specific set of frames. So update will happen every frame, which is something that can vary computer to computer, whereas fixed update is going to be capped. So if you've played a game and is capped at 30 FPS, and I know a lot of people who get frustrated at games like that, they want their games uncapped. The reason why some of those games are capped like that is because they use a fixed update call, which will only happen at a specific frame count. So if it's set to 30 frames per second, changing it might actually mess up some of the code and make things not work as smoothly as they're supposed to. So keep that in mind if you're ever playing something that has a capped frame rate. There might be a reason, and it is keeping the code together. So I'm going to save this, and I'm going to go back into Unity. I'm going to demonstrate all of these things by just hitting play. And then I'm going to open up the console. Oh, and you see I had removed the Unity test script, so I'm going to add that. Boom. So we got the one test from start. And then we can see the fixed update count is going up, and the test update is going up. And they're not going up at quite the same rate, but they're actually pretty close, which is actually kind of surprising to me. Okay, we can see that the update is going a little bit faster now, and that also demonstrates the variation of your computer's frame rate just as it's doing processes. My computer had slowed down for a moment, which is why it was keeping within a 2-digit range, and then it sped up, and now it's slowing down again. Your frame rate in your computer is not always consistent, whereas fixed update will always move at a consistent speed. And you can change how frequently your fixed update calls by opening up the project settings under Edit and going to Time. And then see how it says Fixed Time Step here at the very top? This is what controls fixed update and physics calculations. So there are going to be other functions like onTriggerEnter, which are only going to update themselves at a fixed interval, just like fixed update, because it's a physics call. So keep that in mind as well. We're not really going to talk about physics here. I'll make another video for that later, but just know that if you happen to be working with something like that, that it operates on a fixed update timescale. So if I raise this, I'm just going to do it drastically so that it's evident. I'm going to go to 2. So it was updating every 0.2 seconds. That's what that meant. So now it's going to update every 0.2 seconds. So if I hit play again, you will see that it is going to drastically... Oh, okay. I actually did something that I didn't realize I did, but it's a good thing to demonstrate. So I had hit play, and I realized that I didn't drag the script onto the game object. So I decided to just drag it over. When you turn off play, any changes that you make to your game objects is going to revert back to how it was before you hit play. So I'm just going to visualize this by saying I'm going to change this X to 5. And then I'm going to hit play to turn off play, and it snaps back to 0 as it was. So I'm going to drag the test script over here, hit play again, and I'm going to go to the console, and now you can see that the fixed update is going much slower because I changed that timestamp. Now I'm going to put it back to the way it was, but just note that that's the difference. And while fixed update tends to be less processor heavy because it has to occur typically less frequently than a normal update call, it can make interactions between things that occur on fixed update and things that occur on a regular update. It can make weird things happen with them. Like, for example, I had a scoreboard that updated on an update call anytime something was within the goal area. And then on the fixed update call, I checked the ball to see if it was in a goal area, and if it was, to reset itself to the center of the map. Well, since the update call could happen faster than the fixed update call, it would sometimes register more than 1 point because the update was calculating the point. So it's seen on multiple frames that the ball was still in there because it was between the frame count that the fixed update was checking to reset the ball. So keep that in mind if you're going to be working with fixed update and update together. Okay? So enough of that. Now we're going to work with variables and references. These are going to be a very, very big component of writing your code and making everything do what you want it to do. So I'm going to make some space over here, and you're going to want to put these immediately below the top curly bracket of your script. And there's going to be a couple different kinds of variables that I'm going to show you. I'm going to explain them all very briefly. But first, I'm going to explain the difference between a private and a let me just finish this out. Public float. Okay, so there's 2 ways that you can define your variables and your references. You can make them private or public. And the difference here is going to be if they can be accessed in the Unity editor, or the inspector specifically. Oops, that's the wrong one. So if I go over here, you see that float public has a box here that I can edit, and I can change the number and it'll stay. And I can come over here and I see that float public is what's visible, but private float, or the float private, is not visible. So that's going to be the difference, is that you can't see in the inspector whatever this value is, but you can see this one, and you can change it. And you can also reference it through other scripts to change it as well. Now, you don't have to change the value by going into Unity and messing with the inspector. You can give it a value from the script. Now you'll notice after these two, I wrote the letter F. And you have to put an F if you're defining a float. So what is a float? Well, a float's any number, just period, any number at all. It could be 0.567, it can be -6, it could be -6.5, 6.6, whatever. Any number at all, it can be a float. And you have to identify it with the letter F. This is in contrast to an int, which is an integer, which has to be a whole number. So if I try to type something like 1.2, you get a red line because it cannot be anything other than a whole number. No decimal points allowed. It can be less than 0, so you can have a negative number, but that's it. All right, integer is very easy. Float's also very easy and very useful. So the last variable that I'm going to talk about is going to be something that's called a bool, or as it's called in the longer nomenclature, a boolean, but it will be written just as bool in your code. And I'm just going to call it state. And I'm going to say it's equal to true, because a bool is typically used to identify the state of a certain object. And it's always a true or false check. That's all it will ever be, is either true or false. And you can utilize this to say, if you do something, you can make it conditional. So I'm just going to demonstrate this over here. I'm going to type out some code real quick. So don't worry about this. Okay, so you'll see this code here. I have an if statement, and you'll see it has its own curly brackets. So this is a condition that will be checked for every update, but it will not run what is between the curly brackets if the condition of the if statement is not met. So for this case, it's going to boil down to if you press the spacebar and the state bool is true, then this will happen. So every frame it will check to see if the spacebar is being pressed down and if the state is true, and if so, it will run whatever is in here. So I'm going to get rid of this debug.log because we don't need to clutter up our console, even though we're not going to be using it very much anymore. I'm going to save this, go back into Unity, and now we're going to observe the numbers over here. So I'm going to run this. Okay, now that this is blue, we know it's playing. I'm going to hit the spacebar. Boom. And now these numbers have changed because I told it to. Now if I hit play again and I check off the state and I hit play, and now I press the spacebar again, they don't change because all of the conditions for the if statement were not met, because the state being unchecked is now false. And you can change whether or not this is true or false through other functions of the code or interactions. It's very handy. Now you'll see how I wrote this. So for the public float, I told it to set itself to 8. So when I press true, or when I press space, if the state is true, the float public will always become 8, regardless of its current value. However, you'll see I did something different here for the integer. I told it plus equals 2. So you can put a plus or a minus sign in front of an equal sign to change the value of a number. So this way, it's going to take whatever the integer currently is. So right now it's -1, and then add the number that you put behind it, which is 2, and then it's going to read out that resulting number. So you'll notice it turned to 1 because -1 plus 2 is 1. So if I go into Unity and I change both of these, so I'm going to make this 9 and I'm going to make this 7, and I hit play, and I hit space again, nothing's going to happen because the state is not true yet. So I'm going to check the box to make it true. Now press space here, and boom. This went to 8 because that's always what it's going to go to, but the integer went to 9 because it was set to 7, so it added 2 to that, and boom, now we have 9. So that's some ways that you can write this out. So if you see people using the plus equals or minus equals or whatever, then you know that's what that does. All right, so the very last thing that we're going to talk about is referential objects. So I'm going to write public game object. Oops. I'm sorry, I do this a lot, where instead of autofilling, I just accidentally enter down. I'm going to write an underscore. So here, before I do this, you'll see that it has this green squiggly line. The reason that it has this green squiggly line is because this word actually has its own function within the dictionary that it's referencing to know what's going on. So I'm going to have to change this a little bit, otherwise the script is going to get confused. So I'm going to underscore this because you're naming something here. So right now what this does is we are saying public, so we're creating a box, because all of these things can just be considered boxes that you're going to put values in. Your variables, that you can put in your values, you can fill your boxes directly from here, nice and easy. References require a little bit more to fill their box. So we're making a game object box, and this says that in order to fill the box, you need to give it a game object type reference. You're filling it with a game object. And then this here is just the name that you are giving what you're putting into the box. This can be just about anything. This is for you, and you're going to utilize this name when talking about what's in the box for this game object. So sometimes it can feel redundant when you see people write something out like this: public text. And it's like, well, that's silly. Why would you say text twice? Well, there's a reason. But first, I have to tell you the reason that this is underlined red. So up here, you may notice that it says using system collections generic in Unity Engine. And Unity Engine specifically is in, bright white normal writing, whereas the others are grayed out. So if something up here is gray, that means it's not being used. So I'm actually just going to delete these because we don't need them. However, if we were to delete using Unity Engine, a lot of these words that are green and blue would no longer work because they're in a dictionary that's being referenced by using the Unity Engine. And we can actually add these kinds of dictionary directories to this. There are more than come directly loaded when you open a new script. So I'm going to say using Unity Engine .ui. This is a common one. UI is going to say it's referencing the dictionary specifically for things that are UI elements, canvas, text, etc. So now the word text has turned green because we've added the dictionary that knows what this does. So when you see people write something like public text, the reason that they have to write text twice is because this is the box and it needs to have a text component, and then they're just using the word text because it's easy to know for yourself what you're talking about. I can change this to word, and it is the exact same thing. It's just that normally people tend to keep things named as closely to what they are as possible. And you'll want to have identifiers though if, say, I were to say text, but if I need to reference a second text reference, well, now I'm not going to be able to name this one text as well. So you could call it text1 or whatever it is, depending on what your purpose for these references is. You're going to want to name them appropriately. But if you're only going to reference one text, a lot of people like to just call it the same thing as the type of box it is, basically. So now I'm going to save this, and I'm going to go over here to Unity. I'm going to show you these boxes. So you'll notice here we've now got boxes because we listed them all as public, and they're all empty. See how it says none on each one? There's nothing in there right now. So we have to add something into these boxes on our own, and we can't just go up and say equals, a number like we did with the variables. There's a little bit more to it. So there's two things that you can do to fill these boxes. The first one is you can manually fill them. So you'll see how it says none, and then in parentheses it says game object, because that's the kind of box that we created, and only a game object can go in this box. Now, as I mentioned before, anything that's in the hierarchy is considered a game object. So I could take the main camera and drop it here, and boom, it fills the box. I can also take this other empty game object that has the script on it, even though it is the object that the script is on, and I can drop it there. You can reference the object that the script is on just as easily as you can anything else. Now for the text, if I try to drag this over here, it won't take because it is not a game object specifically of the type text. So I'll have to right click and go to UI and create a text object. And now if I go back to here, I can take this text and drag it in, and boom, it fills. But only something that is of the type text will go in this box. But I could take the text and fill it in the game object box because text is still just a game object. Okay? So that's one way that we can fill these things. So now I'm going to hit this little circle here, hit none to clear out the boxes. And now I'm going to show you how to reference this in code. So if you open this up, you may see people write out something like this. Text equals find object of type text. Boom. So now what this does is you're first saying, okay, I'm dealing with the text box that is named text. You're saying exactly what box you're working with by identifying it by the name that you gave it. And then you're going to, the equals is saying I'm filling this box. And then the find object of type looks for something with the text type, a game object with the text type in the hierarchy, and it puts it into that box. All right, so I'm going to save this. I'm going to open Unity again. And currently the text box is empty. But if I hit play, it is going to fill in because on start, it went through my hierarchy, it found an object that was of type text, and it put it in the box. So that's what doing that does. Now, if I were to create a second text object, text 1, and I play again, you will see that it found a second one, and it filled in with the last one it found. So basically, it went through the list and it just went with one of them, which is why if you're dealing with multiple references of the same type, you're going to have to use something that's a little bit more specific when finding it. You'll have to either tag them or whatever, and that's going to be a little bit more complicated than I want to talk about in this video. I just want you to be aware that sometimes you're going to run into problems where you have to be a little bit more specific with how you find something, or you're just going to want to go through the process of manually dragging and dropping if it's not too much of a hassle, which sometimes it will be too much of a hassle. Trust me, I've been in that situation where I've messed up the finding script and I manually dragged and dropped 100 game objects into boxes one by one, and it was a nightmare. So you'll definitely want to be able to utilize this script to fill your boxes, but just note that if you have more than one thing in your hierarchy that can be found, you may run into an issue. It's not always going to grab the one that you want it to. Okay? So, I think that's just about everything that I wanted to talk about here. We talked about the curly brackets. We talked about, we talked a little bit about the curly brackets. So, anything that's in the curly brackets is always going to be done together, because Unity does everything top to bottom on your script. So we'll look here at the if statement that we wrote. So float public equals 8 is the first line, and integer plus equals 2 is the second line. So technically, this and this occur on the same frame, but this one happens first. And this order of operations can become very important depending on what exactly is going on in your code. So let's just say, for instance, if my integer relied on the float public being a specific value, and we wanted to update that value first, we have to make sure that this line is above this line. Because if we try to utilize a new value before we set it to that value, even if it's going to occur on the same frame, it's not going to work. Oops. So like in this theoretical situation where the integer will only update if the float is 8, well, we're not setting it to 8 until after we're making that check, so then this won't occur. Big issue with something like this that would happen would be if you're dealing with, say, an enemy or a character or something like that, and say, okay, this enemy died, or this object was destroyed or whatever, and you want it to do something like before it dies. You want to utilize any code for it. You want to call an animation to show a death animation. You have to make sure that that is written above the line that's going to tell the script to destroy that game object. Because if it comes up to a game object destroy function, it's going to happen and it's going to delete the entire script that is presumably on that entity, and nothing else below it is going to happen. So keep that in mind. Also, if we had more than one if statement that occurs, so copy, and then we'll just paste the same thing. So we have two if statements. This one is going to occur, and it's going to run everything inside of it, and then this one is going to occur and run everything inside of it. So everything is just top-down sequential. Okay? And the last thing is, I'm just going to talk about briefly these semicolons. You may notice that after everything I wrote out, I wrote a semicolon. And I should have mentioned this as I was doing it, so I apologize that I did not. But semicolons are how you tell your code that the line has ended and that it can move on to the next thing. So if I were to delete this, boom, I'm going to get a red line here after the text. And it's going to tell me, because Visual Studio is very nice, it tries its best to tell you what's wrong. It says semicolon expected. So we can just type that there and everything will be fixed. But if you don't tell it that the line has stopped, it's going to get confused and you're going to get an error, and just nothing is going to happen after that point. So always remember to put your semicolons at the end of your lines, with the exception of being anything that is followed by a curly bracket. So your methods, your start method and your update method and your fixed update, and any other method that you write, because you can write your own. You don't have to use just the built-in dictionary. I can write a method that says void test method. I spelled method wrong. Yay. Boom. So I can now make a call to this method from up here. I can say, test method. And it's going to now, when I press spacebar, since test method is now within the list of things that it can do, it is going to tell it to do whatever is in here. So this is where the top-down situation may not happen the way it looks in the code, because it's going to do this, this, and then this. So then this is going to happen, and whatever is in here, debug.log test method, boom, this is going to happen. And then it's going to go back up to here, because by doing this first, it had to do everything that was in here first, because it has to run everything that's within the test method curly brackets by order of operations before it can move on to what's below it down here. Okay, so methods have curly brackets and will run everything within them. And you can have nested curly brackets with if statements. So if statements will never have a semicolon after them. Neither will the first line of a method. But anything that doesn't have curly brackets following it is going to need your semicolon. And all right, the very last thing that I'm going to talk about, just because it's there right at the start, is you'll notice how it's got these this green writing, and it has these 2 forward slashes here. Forward slashes are indicators for comment lines. Comment lines don't do anything in terms of the functionality of the code. You can type whatever you want after it. As long as you do a double forward slash, you can write whatever gibberish you want, and it will not impact your code whatsoever. The whole purpose of this is for you to leave notes for yourself or the rest of your development team, either explaining what something is for categorization, saying, placeholder, hey, we need to apply this function here, or whatever. It's just a way to talk to either yourself or your dev team about something going on in the code. It's very useful, but it's not necessary to change the functionality of the code at all. You could have 1,000 lines of comment code and 20 lines of functional code, and it's still only going to do the 20 lines of functional code when you actually run the script in Unity. Okay? I think that's everything I have to talk about here. So I hope you found that informative, and I will see you in the next update. All right, take it easy.